to our new format for Reveal. Just a reminder of kind of what we're doing on Monday nights. The goal will be to do this through the end of the year. One thing about Renews, we're not afraid to change things up and try and make things better here and there. The idea was on Monday nights since we're going to 3 formal services on Sunday morning, to not have kind of which the Monday night 242 is sort of a formal service. It's kind of a half service. But since we're doing 3 formal services on Sunday, the idea has been for Monday to be focused on outreach, focused on overcoming objections to faith, overcoming the obstacles and barriers that many people have. And so we're going to probably publish a list of different topics. And each Monday night will be sort of a standalone event. And so the idea will be we'll just do, some family-friendly music on Monday night from 6 to 7, which is similar to what we do on Friday night, only Friday night is a longer time frame. But, just some music, 6 to 7, and from 7 to 8, I'll teach. The idea really is to hopefully have some people that are skeptics that want to come and be challenged, ask questions, deal with some of these topics. And so, the topics will range from things like what I'm going to do tonight, which is a very heavy, detailed science type topic, but it's an interesting bioethics topic, so we'll deal with some of that kind of stuff. But I promise we're not going to do science every week, because I think that will overwhelm and kill most people that don't love science that much. And so sometimes we'll cover other topics like, can you really believe the Bible is real? And we'll deal with that probably, in a couple different formats. Like one night I might do the archaeology of the Bible, showing that the Bible is authentic. We might do, other things like third-party sources that show that the Bible is real and accurate. And so, but other things like I want to do a thing on I don't have enough faith to be an atheist. And what I want to do is deconstruct the atheistic argument. And it would be philosophical but understandable because the things that they think often are things you've already heard. And so taking those piece by piece, deconstructing them, and giving you tools to be able to argue that point if someone wants to argue atheism to you. And so part of this then is going to be preparation and training for believers on how to deal with those kinds of things. And part of it's going to be for hopefully skeptics in the room to overcome some of the barriers to faith so that we'll see people come to know the Lord, which is important. So Monday nights will not be primarily Bible studies. This is a different thing. This is what we'll call apologetics. And I'll define it for you briefly. It's not an overtly important word to most people, but apologetics, which is apologetics. It is not apologizing, has nothing to do with apologizing. In fact, it's the opposite. Apologetics means defending the faith. And we actually see the Greek word apologia used, and we see it in Scripture, and being ready to give a defense for the hope that's in you. That kind of thing is an apologia type concept or construct, which basically means we can defend the faith. And when someone says, why do you believe that Jesus is the Son of God? You should be able to formulate an argument. And if you don't know how to do that, I'll teach you. I'll teach you how to do those things. If you have an atheist that says there is absolutely no God, how would you approach that and deal with those topics? And how would you enter into a dialogue, an intelligent dialogue, without it being a formal debate? But where would you start? What would be the first thing you would ask? For instance, I get the opportunity to deal with lots of atheists and have over the years, especially when I was more detailed or more into the science world. One of the questions that I would ask an atheist almost always first is, do you want there to be a God? It's a great starting question, because if an atheist says, no, I don't want there to be one, you've got to argue a totally different way than someone that says, yes, I wish there was, I just can't get my arms around it, or I don't have enough evidence to believe it. And then a second question for that would be, what do you need to hear in order for you to believe? And then they'll tell you, well, this is what I would need to hear. And then you could knock those off one at a time. Does that make sense? And so those are some of the things I want to teach you. I want to teach you how to do that stuff. And I hope that this group will grow and grow, because I want to teach you how to defend the faith. I want to give you foundation for what many of you already believe. I'm not assuming that everyone in the room is a believer. And if you're not, you're in the right place. And we're going to deal with some of those questions. But if you are a believer, I want to give you the tools so that you can lead other people. Certainly, I'm not the only one that can lead people to Christ. In fact, as a disciple, you're called to be a disciple maker. And so I want to give you tools. And we live in a world that most people, if you were to open your Bible up, most people don't care at all what this has to say. It's not authoritative. Now, the question on that, and I just want to give this, by the way, you're going to probably hear this little speech for this 5-minute speech probably for a few weeks while we're setting the tone of what this new format is called Reveal. Okay? But Acts 17, and this would be worth you going back and reading. I'm not going to read Acts 17. And again, most of these Monday nights, I'm not going to go into detailed scripture, although even if we have a room full of skeptics, I'm not going to apologize for using the Bible. You just have to understand that an atheist or someone that has no belief system in Christianity, this is not authoritative, and so it doesn't help to make an argument from it. Everybody with me? And so we're going to, especially as we get into this a month or two, and we actually can get the word out to our friends that are skeptics, when they come, that'll be more important as we enter into that conversation. But in Acts 17, Paul is a master orator. He's a master thinker, a philosopher. Paul is brilliant. And of course, we see as he tells his story that he's trained with the best rabbis. I mean, he was on the fast track to being probably a high priest at some point, and yet he has this amazing turnaround. But so Paul's a brilliant guy. And what you see, if you read Acts 13, Acts 14, and Acts 17, you will see that Paul approaches each of those groups very, very differently. But he's approaching them with where they are in their own heads. In other words, he takes time to figure out who his audience is, and then he meets them there, and he begins to lead them to the cross. But it's so amazing if you really read it that way, and I encourage you to try it. Read Acts 13, then read Acts 14, then read Acts 17, and see how Paul constructs an argument that's unique and different for each of the people groups. But he always ends up in the same place. It's totally amazing. But in Acts 17, what I love about it is this is a totally non-believing, non-Jewish. They don't have a Jewish construct. They don't have the Old Testament scriptures. They don't believe in Jesus, but they're philosophers, and they love seeking wisdom. And so Paul comes in, he's waiting for his friends, he meanders around town, and as he's walking around town, he's a student of the town. He's figuring out what makes these people tick. What is it that they believe, and how do they think? And so that's when he goes up to them and says, "Men of Athens, I see that you're a very religious people." He doesn't say, "Men of Athens, you're a bunch of stupid, ignorant heathens that are all going to hell," like the street corner preacher that would do such a thing. He doesn't do that. He doesn't do it at all that way. If he did that, they would have been quick to grab him and throw him out of town, or to take him over and stone him, try and kill him. But he doesn't do it. He meets them right where they are. And he's telling the truth. It is a very religious place. Not Christian religious. They have like 30,000 idols in town. And so he meets them right there, and then he begins to speak their language, which he talks about their poets. He actually quotes their poets. And then he talks about their own idols, and he meets them with the unknown God, this unknown idol. And he says, "Hey, I know that one. I could tell you about the unknown idol." Now, was the unknown idol really Jehovah? No, but he meets them there, and he uses that as an example to say, you don't know who this one is either, but I can tell you about one, the one who created everything, and that opens up the door of, ooh, I'm interested, tell me about it. And then he takes them there, and he leads them to the resurrection, where some of them dismiss him, and some of them listen. And I think that's an important message for you, is that you can be the greatest apologist of all time, which means apologetics, the defender of the faith. You can be the greatest defender of the faith of all time, and you still won't reach everybody. Just understand, you still won't reach everybody. Not everyone is going to come to faith because you open your mouth and speak. And in fact, you need to not worry about your statistics. This was something that I had to learn many, many years ago in loving the debate and loving to argue, and especially matters of faith with atheists and all. And it was very discouraging to sit down and talk to someone for 5 hours and give them everything I had, and at the end they still go, "You're still stupid," and walk off. But what I learned over time was that we're called to obedience, not statistics. So if God provides an opportunity for you to be a witness, and that's that Acts 1:8, power to become my witnesses. If you are given an opportunity to be a witness, the outcome is up to God. The Holy Spirit's the one that has to convict the hearts and let them change. But I do think we need to be prepared and ready to give a defense for the hope that is in us. And so that's part of what this is really about, okay? So hopefully you'll bring friends. Hopefully you'll bring friends that will want to come and hear this, that want to be equipped and prepared with these kinds of things. But also bring your skeptic friends. If you have friends at work or whatever that do not believe in God, say, we've got this cool thing that we do on Monday night. It's not heavy Bible. It is talking about matters of faith and overcoming the objections to faith. So hopefully you'll do that. And then we'll outgrow this room like we almost are already. And we'll move into the auditorium. And wouldn't it be cool on a Monday night to talk about, I don't have enough faith to be an atheist, and here's why, and there's 200 or 300 people in the room. That would be awesome. Let's get there. It depends on you to bring your friends that don't believe and have an outlet to do that. And so we're going to work through stuff like that. So human cloning. So last week we talked about stem cells. I'm not going to redo that one. You can go back and watch that. We recorded it, and it's there. The primary, or the big idea was, as we were talking about life, we did five key factors that define life from a biological perspective. I actually used a high school general biology textbook to make the case that these are the 5 things that define what life is. And then what we basically said is a hours-old cell that has been created through sexual reproduction, does it fit the criteria? And the answer is absolutely. And so that was part of that. And it's important that you make that argument. Yes, it is a bioethics topic, it's an abortion topic, all that stuff. But as you begin to make this case, it's important as you start to talk about stem cells and developing stem cell lines that are a primary way they do research these days on medical topics, on medical things. And it came out of the ALS question and all the research that goes into that, and whether or not they're doing research ethically or not. And so different foundations will use adult stem cells, some embryonic stem cells. Embryonic stem cells do not work. They do not create life. They do not create good, healing, curative medicine. Never have, and we've been doing it for decades. It does not work. But embryonic stem cells, you create a cell, and after it divides enough times, you peel open the cell, you basically kill the cell, and then you can dissect out the stem cells, which are generic cells that can take on the attributes of other tissue. So for instance, if you have damage to your liver, we could use stem cells, which are generic cells, put those stem cells with your liver, and it would begin to create new liver cells. But again, I'm not going to re-explain the whole thing. You need to go back and watch last week's. But human cloning is a tied topic to this, because human cloning is one of the ways that researchers have been trying to figure out how to create new lines of cells to do research with. The challenge with human cloning is that most people have a perception that human cloning is only something you see in the movies. If I'd had more time and didn't have to play music for an hour, I could have found this clip for you. But how many of you have seen Jurassic Park? Anybody? How many of you are scared to death of Jurassic Park? How many of you love Jurassic Park? How many of you just don't care whatsoever? Just want to get on with it? Okay, so, but you remember the old guy, and it's been years since I've seen it, but he had the mosquito and the amber. Remember that? And the tree sap. And they basically, drilled in and were able to find the blood inside the mosquito of a dinosaur. And then they took that blood out, and they were able to basically, here's the generic answer. They took the DNA from the blood of a dinosaur that was in the mosquito and crossed it with a reptile, a large reptile, and were able to jumpstart it to begin to create this new organism that was an ancient dinosaur. Okay? So that was the basis of Jurassic Park. Most people think that's what cloning is, and it's just science fiction. The truth is, cloning is not science fiction. Cloning is reality. We have natural clones occur, and I'm not going to get into that, and we'll define cloning here in a minute. But we've been playing with cloning for a long time, especially in the plant world. Hundreds of years have been cloning. For instance, like bananas, those are hard to propagate, but they're easier to clone an existing banana. If you have one that has the right kind of genetic makeup, it's easier to clone that than to try and create new things. But with hybridizing fruits and things like that, and creating some of those kinds of things, it is a cloning process. And so we have to kind of know what cloning is and what it looks like, what it means, what the ramifications of it are, and all that good stuff. And so, for you, now I'm using a PowerPoint that I've used to teach in various places around the country. And what I'm going to share with you is easily a 3-hour lecture to postgraduate college level students. So I'm not going to do that to you. I'm going to teach at a high school level. I'm going to try to anyway. And I'm going to skip a bunch of slides in this. But I want to just give you some tools here, okay? So I've got on here Jurassic Park, the little dinosaur. So it's an important issue. What was once science fiction is real. And it is one of the most challenging topics, honestly, from a bioethics perspective. You don't hear about it a whole lot anymore, but it's still going on constantly. There are private organizations that are striving to clone humans as we speak, and they have not been successful, but they're continuing to try and try and try and try. They are cloning animals, and they've cloned all kinds of animals. What's the most famous animal clone that you know about, and most of you were alive when that happened? Dolly the sheep, which was in 1996, if I remember correctly, and they cloned Dolly. Now, or they cloned Mama and created Dolly the sheep. Now, Dolly had some problems. Does anyone remember? Did anybody read any articles about it or watch it on the news? Anything? So there's part of the problem. So you hear those things happening, but then we only get part of the story. And so we get all these perceptions of what clones are and how they work, and the reality is they're usually messed up. And so we have all this perception about what cloning is about. Perception is just a belief system based on what you think. And the problem with cloning is what you think is probably based on movies, right? So for instance, one of the real challenges when you talk about human cloning is you might remember old Star Trek episodes or things like that where you get into this chamber, right? Like, I want to clone myself, so I get in this chamber and all these lights flash, and then out comes my clone, and out comes me, and you can't tell the two apart, right? Most people have that perception. That's what a clone is and how it works. But the reality is not at all. And so the reality is that we need to have good science and understand it. And you need to know it because God created things a certain way. And He created things to be a certain way for His own reasons. And sometimes we can mess some stuff up. And we start to get down the road of trying to do new, innovative things, because the thing is, researchers, they love to do anything they can to be innovative. But the truth is, sometimes they throw ethics out the door in order to try and be innovative. And so we need to make sure we have some good science and understand it. because it is a topic that will come up. All right. All right, so our objectives then, we want to make sure that we define cloning and human cloning, how it's done. There's a couple different types, and what are the ramifications of it. That's probably about as far as I'll get. Let's see, yeah. And so what is cloning? So cloning is the process of creating an identical copy of the original. Now, a human clone or any animal clone, my real definition is it is a time-delayed identical twin. Everybody with me? So a clone is a time-delayed identical twin. So if I were to clone myself, basically what I'm creating is my identical twin, but a time-delayed one. You don't create an adult. You would create an embryo with my same genetic material that would have to grow just like I grew, and it would take that long. So that's the first reality when it comes to perception versus reality when we begin to talk about cloning. So if you, like when Dolly the sheep was cloned, they did not put her in some hyperbaric chamber and flashlights and out popped an adult sheep. It wasn't that way at all. They had to manipulate the genetics a certain way and create a new embryo and allow that embryo to grow and to develop. I won't show you the pictures from last time. To grow and develop, implant it into the womb of a sheep and allow it to grow just like normal and be born just like normal. And so clone is a time-delayed identical twin. Everybody with me? Okay. So cloning, again, I've said some of this already. All right, so what is human cloning then? It's creation of genetically identical copy of an existing or previously existing human. Again, we've been doing cloning though for a long time. Chickens and sheep and pigs and all that, we can clone those things. But humans, that's a totally different topic, and that's really the only thing that matters to us really, but I'm going to explain the process to you. But it's definitely a debated issue. So how is it done? Well, there are two main phrases. Now, there's actually a newer third model, but it's not even worth talking about because as far as I can tell from the research I've done, it's so new in what they're trying. It doesn't work, and I doubt it ever does. But these are the primary ones, and this is the primary one. It's called SCNT, somatic cell nuclear transfer. Hey, Kirk, if you're back there, can you find me a marker? Okay, so last time we talked about two different types of cells. You have somatic cells, and you have sept cells, or gametes, if you've studied biology recently. These are the only two types of cells that you have. Each of your somatic cells, somatic, soma means body. Every cell in your human body, except for the sept cells, so except for egg and sperm, every one of them has 46 chromosomes, which are two sets of 23 chromosomes, okay? If you remember the double helix, you have two sets of identical stuff that's wrapped together, and that makes up your 46 chromosomes. But it's really two copies. So it's 23 plus 23 make up 46. But in a sept cell, an egg or sperm, there's only one set. So you have 23. So that way, when the egg and the sperm come together, each of them donate 23, and now we have 46. Everybody with me? One of the points that I made last time that's really important when you begin to understand this topic is when those 23 chromosomes from dad and 23 chromosomes from mom come together, within hours, a process called crossing over occurs. And this is what the process to determine what is recessive and what's dominant. So whether the kid's going to have blue eyes or brown or curly hair or straight or brown or blonde or whatever. Thank you. So that happens within hours. At that point, once crossing overs occurred, that is a completely unique organism. It is no longer mom. It is no longer dad. It is completely unique genetically. It's its own individual, which is important, and people ask that all the time, especially when it comes to the abortion topic or whatever. Biologically speaking, within hours, it is totally unique. And so I didn't talk about this last time, but hey, why not talk about it? We can debate it if you want to, but it'll get us off a cloning topic. But the old argument is, it's my body, my choice. The reality is a fertilized gamete, a fertilized egg, is no longer your body. It is totally unique genetically within minutes to hours. And so that argument doesn't really work from a biological perspective. Now, from an ethics perspective, people can think whatever they want. But biologically, once that egg is fertilized and crossing over has occurred, it is no longer your body. It is no longer genetically the same. It is unique individually, okay? And so a somatic cell is a body cell, and a sex cell is an egg or a sperm, okay? So every cell in your body, whether it's in your eyeball, or your liver, or your kidney, or your big toe, or your fingernail, every cell is a somatic or body cell. Every one of those has 46 chromosomes, but those some of those chromosomes are turned on in different cells to make them specialized to be certain cells. So a liver cell, for instance, just one little itty-bitty piece of that 46 chromosomes is what is realized, and it becomes a liver cell. But all the genetics for the entire person are still there. Everybody with me? They're just not turned on. They're just kind of dormant in a sense. But the whole genetic package is in every single cell, even though just a little piece of it's turned on to say, oh, I'm a liver cell, or I'm a big toe cell, or I'm a cell that goes to the fingernail. This is one of the amazing, amazing, amazing miracles of cellular development, is how do those cells specialize and know what to do. And they know what to do because there was a master plan blueprint that was created right into the genetics that is absolutely 100% amazing. And even your atheistic scientists would say, yeah, it's hard to understand how that functions that way. And so the way that cloning works then is a somatic cell. So everybody with me? It's a somatic cell nuclear transfer. Now I have a picture there, but I think I'll just draw it for you. And so here's our cell from last week. And so in this cell, you have, this is your nucleus. So within here you have 46 chromosomes. You have endoplasmic reticulum and ribosomes and Golgi bodies and lysosomes and mitochondria and blah, 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 all the organelles that are built into the cell, right? So this by itself is amazing, irreducibly complex. If evolution were true, this cell with all those little itty-bitty components would have had to have evolved at the exact same moment in time through random mutational events in order to get one cell to come into existence in one moment. That is ludicrous to the highest degree. It is irreducibly complex, just like a mousetrap. If you think about a mousetrap, what part of a mousetrap could you take off and have it still function as a mousetrap? Is there any part of a mousetrap you could take apart and take off and have it still function as a mousetrap? Anything?
Sticker.
No. Huh?
The sticker.
The sticker, there you go. But of the mousetrap itself, it is irreducibly complex. It's a complex mechanism, so it has a platform, it has an arm, it has a spring, it has a lever and a switch. There's not one thing you could take off of that and have it still function as a mousetrap. It's irreducibly complex. It's a complex mechanism, multiple parts are working at once, and it's irreducible, which means you can't take one piece off and have it still function. Guess what? A cell is irreducibly complex. You cannot take the mitochondria out of a cell and have it function as a cell. You cannot take the endoplasmic reticulum or the lysosomes or the nucleus or any of those things and have it still function as a cell. So again, from a creation perspective, if I were debating my friend over here, I would say, explain to me the evolutionary mechanism of cellular development with all those components evolving at the exact same moment in time. And they would laugh uncomfortably because there's absolutely no answer. There's no possible way. So the way that cloning is done then is you have this cell, a somatic cell. It has 46 chromosomes. And so we get this process called somatic cell nuclear transfer. So basically here's what we do. So let's take an egg cell. Now a human egg, a female egg, is one of the larger cells in the body. How many chromosomes would a female egg have in it? 23. And so we have a nucleus there, but only 23 chromosomes. And so in somatic cell nuclear transfer, you basically pop the nucleus out of the egg cell. Now you could use various types of cells. You could use skin cells. Sometimes they use mammary tissue because those cells tend to be pretty big also. but just using an example for here. And so they would pop out the nucleus of a Sept cell. They would pop out the nucleus of the somatic cell, and they would put the nucleus of the somatic cell into the egg cell where the 23 chromosomes used to be. And so they pop this out, they introduce it into the egg cell, they pass an electric current through it which will fuse the now 46 chromosomes into the egg cell. In the right conditions, it will begin to divide just like it would under sexual reproduction. That's called a somatic cell, 46 chromosomes, nucleus transfer. Somatic cell nuclear transfer. Everybody with me? So we take the egg, we pop out the 23 chromosomes, discard it. We take another cell from a mammary tissue or skin cell, we take that nucleus out, and with a micropipette, we put it right back in there, pass electricity through it, fuses that together, and in the right conditions it will begin to divide. And then that one cell will become 2, and the 2 will become 4, and on it goes, just like sexual reproduction occurred. Okay? So that's human cloning, in essence. That's what it is. Because what you're doing now is you're taking, remember, every cell in my body has this genetic makeup. It is identical to this. And so now, what am I doing by popping this nucleus out and putting it with the egg cell and making it divide again? I'm creating a time-delayed identical twin for myself. Everybody with me? Mm-hmm. Okay. So there's pictures of it. So this is what they did with Dolly. So this was the process they used. And so they basically removed an udder cell from this sheet. They removed the DNA from fertilized egg. They fused the two together. And then here's the cloned embryo. Now this is where last week we talked about once it begins to divide enough, it'll become a ball of cells. If you remember from your general biology class, it's called a morula. It's just a ball of cells. But eventually that begins to divide and creates a little cavity, which eventually is the gut tract. From my mouth out is what this opening actually becomes. And these cells that are inside are stem cells. They have not specialized yet. They're generic cells that can be either used as embryonic stem cells in a laboratory setting, which once again does not create life, does not create any curative medicine. In fact, it usually creates tumors when they use embryonic stem cells. Or they take this embryo, and it is an embryo, even though it was not created through sexual reproduction. They've created a dividing 46 chromosome organism here. It's an embryo. They can implant it into a surrogate mother, and then it gives birth to a clone of the organism they began with. This is exactly what they did with Dolly. Okay, let me stop there. It's pretty complex. Everybody with me? Does that make sense? So again, the easy answer is you pop out the nucleus of the 23 chromosomes, because 23 don't do you any good. You need all 46. They pop out the 46 from a body cell, put it in the egg cell that once had 23, shock it, and it will begin to divide and basically becomes an embryo. Okay? So that's what it is. Now, with humans, it would work exactly the same. Remove a skin cell from a patient. How many chromosomes would that skin cell have? 46. Remove the DNA from an unfertilized egg. So we take an egg from a woman, pop out that nucleus that only has 23 chromosomes, put the 46 chromosomes from his skin cell into that egg, shock it to life, basically, which makes it fuse. It begins to divide, and then they can, and theoretically, they would implant that into a surrogate mother and create an identical twin of this dude. Or they rip this open and try and get the embryonic stem cells and use them for research. In theory, that would be what they would do. Okay? Everybody with me? Okay. Anybody see any bioethical challenges with all this process? Okay. We're going to make sure. Okay, so it's different from sexual reproduction only in that you have two 23 chromosome entities, sperm and an egg. They come together, which make us 46 chromosomes. Theoretically, it implants into the wall of uterus. It grows, and that's what's different. And so you're not using a sperm cell in order to create a human clone. You don't need it. You're creating a time-delayed identical twin of the host, okay, or of the donor. So there's two intents of human cloning then. Why would we do it is really the question. And so the first one is reproductive cloning and the other is therapeutic cloning. Now, this is where politicians, I'll be very careful here, but this is where politicians and scientists love to argue. And they would say, well, we want to do research on human cloning. We want to produce clones, but only for therapeutic reasons, not reproductive reasons. Here's the only difference between therapeutic and reproductive. What they would say is therapeutic is they want to capture the stem cells, which would be to destroy the embryo and pull out those generic cells to use for research. A reproductive clone would be implanted into a uterus. The only difference is whether or not it's implanted into a uterus or not. Everybody with me? But scientists and politicians go, oh, well, human cloning is a great thing. We will only use it for therapeutic purposes. We'll never do reproductive. Well, all it takes is one scientist to create the morula, the ball of cells, to implant it and hope that it works in a reproductive way. And so what you'll often find, and there are laws on human cloning they're different no matter where you go in the world. But it's a topic that's dealt with, and many of them will say, well, it's illegal to do human cloning for reproductive purposes, but it's okay to do it for therapeutic purposes. But there are private organizations that don't take any government funding that are trying to create a human clone. Now, as far as I know, there have been no successes in creating a human clone. Now, you could go do research and find out that I'm incorrect on that. I tried to spend some time today looking to see if any advancements have been made. And as far as I can tell, no one's either talking or no one has been successful. One of the things that they've had as a dilemma of all of somatic cell nuclear transfer is it's very inefficient, which is one reason you should never do it. I mean, one of the arguments we made last week with stem cells, you don't need to do embryonic stem cell research. It has never been useful for curative medicine ever. It only creates havoc and problems. And it's a bioethics nightmare because it is an abortion topic. You create an embryo and destroy it in order to capture certain cells. But with an adult stem cell, there's no bioethics issues whatsoever. And by the way, I talked about, we've been doing adult stem cell research for decades and we didn't even realize it, like in a bone marrow transplant. And someone asked me a question, they did some research on it and said, well, with a bone marrow, you do have to have a match, like a blood donor match. But stem cells themselves are generic. I could give you my stem cells, you could give me your stem cells, and there's no issue with them being shared. But when red blood cells and other tissue is donated, especially in bone marrow where you have a complete genetic package, you need to have a match. But the stem cells themselves you can share those. And so we've been doing bone marrow transplants for decades, and we didn't really realize what was actually causing the cure until we started researching stem cells. So that's it. But with this, it's incredibly inefficient to do this in order to do therapeutic cloning, just to create cells in order to have an organism. The research says the success rate on trying to create a cloned organism through somatic cell nuclear transfer is 0.1 to 3%. So out of 1,000 efforts, at best, you're getting 3%. You know, it's just not worth it. It's not worth the time. It's not worth the energy to get 30 dividing cells that still may never do anything. But with adult stem cells, you can go on. So the only reason they would do this, the only reason why they would try the human cloning is to do it for reproductive purposes. They're trying to get there. But again, let me just say, I will tell you now, if it changes, I would be the first one to admit I'm wrong. But I'll tell you my bias. They should have figured out a human clone by now. But and there are plenty of private organizations trying to. I will tell you, I think there's a stopgap that God created in there to prevent that from happening. Because if we can clone chickens and frogs. Frogs are one of the first ones. Sheep, mice, those kind and pigs. We should be able to clone a human. And so if it's happening, no one's talking about it because of the ramifications of it, or there's a stopper that's built in that doesn't allow for it. Just like as I've talked here on Monday night before, that there are genetic stops put in place that don't allow evolution to occur. For instance, you can mate a tiger and a lion together, and it makes a fancy animal that what was his name? Napoleon Dynamite loved, the liger. That is a real organism, but it is sterile. It can't have offspring, and so it's not truly a different organism from an evolutionary model. There's a stop that's built in, and so you can make different organisms together and produce an offspring. But when they're two totally different organisms, they're always sterile. And that is one of those things that's like, from a geneticist perspective, there's really no reason why that would be, but it is. So why is it? Well, I think it's because God created a stopper there to keep us from doing stupid things like that. I think that's the answer. And so, there you go. So, again, reproductive versus therapeutic. We create the clone through somatic cell nuclear transfer. If you rip open the cell and steal its stem cells out to do research, that's therapeutic. If you implant it, it's reproductive. And that's the only difference. But the process is identical no matter what, which is what I talk about here. All right. So both of those, go back. Both of these create life. And so if we go back to our original document here, if we were to, and where this came from, again, you need to go back and watch last week's. But if you were to find a blob out in the forest, and if you're a good scientist and you would say, is it alive or not? The 5 primary questions you would ask is there reproduction ability? Is there heredity? Is there cellular organization? Is there a metabolism and homeostasis? If you create a somatic cell nuclear transfer organism, it still fits the definition. You're creating an embryo. Now, it's a time-delayed identical twin embryo, but you're creating an embryo. So that's where the challenges come in. You're creating life. But again, it's a perception versus reality issue and what you think about that. So, all right. So the question then is, we start to ask these questions. Does an embryo fit the definition of an organism? If not, what is it? Well, we just defined that. It certainly does. What characteristics define life? Does the embryo fit this definition? Absolutely it does. And so any high school textbook will tell you that. But it's still one of those crazy things that scientists like to debate and confuse us over. And so let me push past some of this stuff. Let me go back here. Okay, so why would people clone humans in the first place? Why would they try to? There's lots of different reasons. One would be to mass produce organisms with desired qualities. And so, for instance, let's just take it to the farthest degree. Let's say that you decide you want to have, you don't want to create a baby the normal way, and so you decide that you want a 6'4", blonde, curly-headed, blue-eyed boy. That's the child that you want, who is an athlete and sings well. Theoretically, you could, through a laboratory process, find people with those genetics, the professional athletes that are 6'4", blonde hair and all that stuff, and create the perfect embryo through somatic cell nuclear transfer. And implant that. Now, you're only going to get 0.1 to 3% chance that it's going to work, so it would be astronomically expensive and time-consuming and difficult. But this is one of the fears of human cloning, that people will go, well, I want to create a kid that is has great sports abilities, and they're strong, and they're big, and blonde-headed, and blue-eyed, and whatever. And so the fear of human cloning has always been, and we get this because we begin to watch TV and movies, and you see those things happening. It's a real fear if the human cloning process was real, if it would actually work, which, as far as I can tell, it never has. But theoretically, you could do that. Or recovery of a lost loved one. So, let's say that you have a child that dies, and you want to clone that child. theoretically, you could take a body cell from that dead child and take it to the laboratory, and they could take one of mom's egg cells, take the child's 46 chromosomes in the nucleus, do a somatic cell nuclear transfer, jumpstart it, implant it in mom, and she would give birth to an identical twin to that child, or give birth to her own grandpa, or whatever. Because the idea would be you can clone any organism as long as you have the 46 chromosomes. This, again, is one of those concerns and fears of if reproductive cloning worked and we got it to work, what is the end result? How far would people take that? The other one is eugenics. I'm not going to spend a lot of time here. You can go look that up. But it's a social philosophy which basically advocates having an improved human heredity. This is what Hitler did. Hitler wanted to exterminate certain genetic packages from humanity so he could create one breed of people that he thought was best. Plato talked about it. Darwin certainly understood this and talked about it from a selection perspective, that you could create a super race of superhumans if selected properly. This is called eugenics, which is we get rid of everybody and we custom make and create the perfect person. And now people that would debate for this would say, yes, but if we could clone people that didn't have any of the genetic markers for disease, we're creating humans that wouldn't have disease, and we could make them look however we want or whatever. But this is the debate. This is part of that bioethical dilemma that exists when we start talking about it. And we have to ask the question, is this what God intended and how he designed it and how it would work? So some of the problems then that we just bring up, and you can deal with them. If we were to debate these bioethically, we could do that. And I know it's small, but the questions on an ethics perspective are what rights would a clone actually have? So if I were to go to the lab and clone myself, who owns those cells? Because when you're an identical twin, the identical twin doesn't own the other twin, right? I mean, you're not ultimately responsible. So if I were to clone myself, do I have ultimate authority over that clone? Who's in charge of that clone? What does that look like? Does that make sense? Because all you're really doing is creating a time-delayed identical twin. So who's the parent? Is the parent the scientist, or is it the donor? Is the one who provides the egg cell that we pop the nucleus out of, is that really the mother? Or is the original mother that created the original cell the mother? You know what I'm saying? We don't know what to do with that. Those are the open debates and the questions. You know, who's responsible for when things go wrong? Could we kill a cloned human if we found out that they were defective? This is one of the other challenges. So let's say that we clone an organism and we go, we made a genetic mistake. It's not what we intended. Do we have ultimate authority to end that clone? Because it's just a clone. One of the challenges you'll find with cloning, let me wait till physically. So those are the questions. Would a clone be treated different in society, assuming anyone would know? One of the questions always has been, well, wouldn't it be good if you had liver failure, and instead of taking all the anti-rejection drugs and getting a liver transplant, what if we could just do away with all the transplants, and if we know that you're dying of liver failure, we can just clone for you another organism that's like you, a time-delayed identical twin, and once it's born and grown enough, we'll kill it and take the liver out, and we'll give you the new liver. Now, these are the real debates on this topic. I'm not making this up. This is the real question. Could we do it? Because again, the clone isn't like we can just pop one out through, the teleporter kind of thing. It's you would create a time-delayed identical you. It would grow. It would be born and have to grow. But let's say that you grow that kid for 3 or 4 years. It's your clone, and you need the liver, and we end that thing and take the liver because it's you after all. Well, it's not really. It's a time-delayed you. So but again, if we were debating it, the question would be, does one twin have the ability to do that to the other twin? but it's that constant concern on how would that be seen ethically. When would a clone have legal or human rights? A lot of people said, would a clone have a soul? My answer for that is, it's a time-delayed identical twin. You're basically creating a twin. And so I would assume so, but it's definitely not done right. But again, as far as I can tell, humans have never been successfully cloned. Could a black market arise for desirable fetuses like athletes, singers? What if living or a deceased person were cloned without his or her knowledge or consent? Think about how easy it would be to capture skin cells off of someone. You could capture a skin cell off of someone in a crowd with just your fingernails. One good gouge there, and theoretically you could capture those skin cells and clone that person that way. Theoretically, it would work that way. A skin cell's big enough that you could do somatic cell nuclear transfer with. So it just opens up the door to all kinds of crazy stuff. And then chimeras, which are a mixture of two or more individuals in a single body. So physically, some of the challenges, though, is most animal embryo clones are horribly disformed and they die. So most of the time, clones, when they're successful to actually continue to divide and be implanted, if they go anywhere, they're usually deformed. Almost always, their internal organs are enlarged dramatically. And again, this, even in sheep or whatever, that was why I asked the question about Dolly. Dolly had enlarged organs and did not live very long. Now, part of the question has been, why did she not live very long? Was it because of the enlarged organs or because of other problems? And so cloned mammals often have oversized internal organs is the last one on it. Here's one of, so this is a deeper science thing, but let me just give it to you real quick. So one of the things that God created in our chromosomes, which is really amazing to me, is this thing called a telomere. And so if you were to look at one of your X chromosomes under a microscope, it basically looks like this. That's what an actual chromosome, so this could be like your 19th chromosome or whatever, and that's what it looks like, okay? At the end of these chromatids, or the end of the chromosomes, you have a thing called a telomere, which is T-E-L-O-M-E-R-E, a telomere. A telomere is basically like the little plastic piece on the end of a shoelace, okay? It's a protective piece that keeps chromosomes from, in essence, sticking together and then coming apart and pulling parts of the genetics apart. And so it helps them to not stick together and all kinds of things. But one of the most amazing things that we found, now this is debated, but I think it's accurate, that every time a cell divides, and because in order to divide the cell, it has to basically duplicate itself and create a copy of it, and then the cell will divide and come apart, okay? Well, in order to do that, it has to make a copy of this 19th chromosome. Every time a chromosome is copied, it shaves a little teeny tiny piece of the telomere off. What that means then is every time that the cell divides, another little piece of the telomere is shaved off, which what that basically says is that your chromosomes have a very definitive lifespan. They will only divide a certain number of times. Once the telomere is gone, it can no longer function. And so it basically will be reabsorbed or fall apart, okay? And so one of the interesting things when it comes to cancer research and stuff like that is watching telomeres and how they function in rapidly dividing cells. And if we could find a way to control one of the enzymes that affects this, which is called telomerase, which is just an enzyme, we might be able to stop the development of cancer cells by getting this done and killing off the little shoelace piece, okay? But what happens then is each of these are shaved off every time that cell divides. And you have trillions and trillions of cells. Every time they divide, a little piece of the telomere is shaved off. So what happens then is, if we have a sheep, if we had that picture, I don't have the picture anymore. If we had a sheep, mama sheep, that is 4 years old, when we capture the body cell from mama, those cells, that cell that we're capturing, has already been dividing for 4 years. And so theoretically then, what happens if we use that as now our embryo cell that already has 4 years of telomeres being shaved off? What does that do to the lifespan of the new organism? Well, its lifespan is already shortened by 4 years because the same cell has been dividing already for 4 years. So theoretically, a human clone or any clone will not live as long because the telomeres have been shaved off already, which is, again, just one of the challenges physically of the clone. This is just a funny cartoon. I don't know if you can see it. We're ready to harvest some organs. Now, which one of us is the clone, or which one of you is the clone? They're both pointing at each other. That was a funny newspaper article. Yeah. So, again, why clone in the first place? We'll finish this up in the next couple minutes. You know, they will say we want to do therapeutic cloning. We want to reproduce organs and organ systems. Somebody asked me last week about the ear that was developed on the back of a mouse, a naked mouse. That was not really cloning. What they did was they took cartilage from a cow and they basically created a titanium mesh that looked like an ear, and they were able to get the cartilage to continue to divide and fill up the space, and then they implanted it underneath the subcutaneous layer on a mouse that's a hairless mouse. And why they do it on that particular organism is because it doesn't have rejection issues like other organisms. Like if you took cow cartilage and implanted it in under your skin, your body would react violently and would try and get rid of that thing, right? But this particular mouse, it doesn't have those issues, and so they could implant it and grow this kind of skin on it and then hopefully be able to use it. So you're going to see more of that kind of stuff. It's not really cloning. It's kind of a totally different topic for a different time. But what they're really wanting to do with therapeutic cloning is be able to create organs or organ systems. So instead of creating a whole human, they can capture just part of the genetics out and create just the parts that you need. So you have an extra liver around or an extra kidney if you need one. And so they talk, and then they say they want to cure disease through stem cells, but it doesn't work. And so then with therapeutic cloning, we already covered this ground. Therapeutic cloning would just be, doing it for research purposes as opposed to reproductive purposes. The only other thing I would say is the ethics behind it are incredibly challenging. And we already talked about some of that, but with, the real answer for cloning is we just need to stay away from it, in reality. To me, again, I'm pretty confident that there's a built-in lock that will not allow that to occur, but I could be wrong. The next 10, 20, 30 years may prove me wrong, and that's okay if it does, but the bioethical side of it is amazingly challenging, and hopefully you see that. But ultimately, I'll finish it with just this one statement, and that is, God created something so amazingly complex that when you hear all these things, it should really do that for you. It should say, there's absolutely no question that an intelligent being created this, as opposed to this was Darwin's warm pond, where inorganic molecules decided to have a party together and all of a sudden created living structures. It is just absurd to believe that inorganic molecules would create this complexity. And again, if I were debating it, someone would say, but if you give it enough time, but that time argument's an easy one to go to because, of course, we can't give it enough time. We don't have the ability to do that. But just because you do something longer does not mean it's better. Someone actually said earlier when I was whining about playing guitar tonight that practice makes perfect. Well, perfect practice makes perfect. And so that's the old coach in me. Yes, I used to coach. If you do something stupid and wrong 1,000,000 times, it will still be stupid and wrong at the end. You just perfected how to do it wrong. And so to assume that we can take inorganic molecules randomly and fit them together to create this complexity or this complexity through random mutations, which are almost always negative and detrimental to random effects, is ridiculous. God is creator, created you with purpose, with design, intended us to create life a certain way with Him, and as He created it to be. And this is a dangerous road to travel, but they're traveling it. It doesn't make media attention very often, only when they clone some weirdo organism, and it lasts for about a day, but researchers don't want you to know about it. but it's a real issue, and our kids or your kids' will definitely have to be confronted with these topics. But hopefully, what we see in it all is God created an amazing thing, and I think we can be in awe of it when we see it. And of course, the other side topic of that, which we covered briefly, is it is a life issue. What is life? How do we see it? How do we look at it? Unapologetically, I will tell you, biologically, it's easy to make the case that God created life a certain way, and it begins right there at the beginning, conception, and we can see it, and it's important. So, all right, that's all I've got for tonight. I will publish our topic for next week, and I'm not exactly sure where we want to go. If you have things that are burning in your mind, or maybe if you are a skeptic, I would love to hear what topic you need to hear in order for you to believe. And so if you're a skeptic in the room, shoot me a text, send me a note on Facebook, come tell me right now. I promise not to debate you on the spot, but I'll create an answer for you and we'll do it. Okay? So that's important. So if you have those questions, let's cover that ground. Otherwise, next week I'll let you know, probably on social media, what our topic's going to be. And hopefully you will invite some friends and we will overcome some barriers to faith that people have, teach you how to cover that ground and to speak intelligently about it, and hopefully lead those who are lost to Christ. Because you can do it. God will empower you to do it, but you need some knowledge. So we'll do that. All right? Thanks for being here tonight. I love you, and have a good night. We'll see you. Hey, lots of stuff this week. Let me just say, Financial Peace University starts tomorrow night. Talk to Kirk if you have questions about it. Wednesday night, Awana kicks off, 18 months through 5th grade. We want your kids here. Of course, youth group will be going on. And tonight at 8:30, we've got our men's study upstairs. And check out the calendar. There's all kinds of stuff going on the rest of the week. Okay? Have a great night. We'll see you.